So a few hints on stopping warping. If you notice, this particular print has curved sides. That's specifically to stop it warping. Straight sides tend to warp. Also notice the extra ridge I put on the outside, and just for good measure, clips that I clip on after it's printed for a little bit. Clips aren't strictly necessary. I think I could have got away without them on this particular print. That's the top of this box, and as you can see, I'm experimenting with putting ridges in on the gaps and ridges. And again, you can just make out these vague lines. They're actually hollows built into the surface. And this did actually warp a tiny little bit, but not enough to be a problem. Here it is again. You see these extra ridges on the outside. They're not part of the model. They are simply there to to make the raft bigger, to make it more difficult for the model to pull up off the raft, because he effectively made the raft larger by adding these reinforcing ridges. And I run the bed temperature as hot as it'll go. On the Zortrax, that's around 105 degrees. On this printer here, it actually goes up to 130. And in fact, what I've actually done is fitted an override switch, which bridges out the control on the motherboard, feeding the power supply straight onto the bed heater. But you have to really know what you're doing. If you get that wrong, it can blow your whole machine up, destroy your motherboard. So you need to understand. If I flick it the other way, the heat goes through, the current goes through another resistor, which is actually another heater bed I bought second hand. That reduces the current, and the bed sits at about 110 degrees. So if I put that down, it'll probably overheat actually. So I never leave that down. I always man it. But that's the setting I normally use. I've got to fit one to this old beast that I need to do up. But that's a real embellishment. I'm going to what I actually want to do is fit a control that causes the machine to think it's actually a bit colder than it actually is, by tweaking the sensor circuit so the raft goes up hotter naturally on its own, particularly that one. Because I actually do think if there was one thing I would change on the Zortrax, it would be a hotter bed temperature. People say, oh, you know, 80 degrees for ABS. I find the hotter the better. And this here is what I printed this on. This is the raft for this. This was sat there like that. And again, you can see the extra ridges I added to make the raft bigger. And so the bigger raft is less likely to pull off the build plate. The other thing is, you might notice the colour of the raft is different. That is simply down to the fact that I was using up a reel of old filament. I print the and then I just swap the filament over, because that's Zortrax ABS. ABS does tend to warp. For the bulk of the model, I'm actually using Zortrax, oh, what is that? ZHIPS. No, beg your pardon, it's not, it's Ultrat. That's ZHIPS. This is Ultrat, which is a form of ABS that Zortrax do, which is a bit less prone to warping anyway. And also, you look at the way I designed the model. There are little cutouts here in these framing bracing pieces, and there again, what I'm doing is avoiding very long straight runs, because it's the long straight runs that that can cause a real problem. So I've got a straight run there, but then it goes around the corner, and I've got a straight, then it goes around the corner there, and then that bit there is set at an angle, and that bit there is set at an angle. It's just so that you don't get long tensile stresses building up across the width or length of the print. I use the hottest bed temperature I can. I use the least amount of infill I can, because infill tends to cause a buckling effect, particularly on solid print. Something like this, it won't be so bad, but when you got a solid base, you run the risk. This is upside down, by the way. As they say, it comes a bit of a job designing stuff as in curves. It would be often easier, even if you can't get the curves, just round off the corners. That helps. And let's turn it the other way up, and there it is. That's what this is. It's actually the cover for a control console, and this is SketchUp, by the way. This is done in SketchUp, but you can SketchUp, you draw a shape. You can draw a shape. Let's draw a shape. Draw a shape, and this ingenious pull tool. You pick up the shape. Actually, I've done that wrong. You use this tool, kick on it, and backspace. I'm finding it difficult because I'm using a phone. There, you see that? You see how I can make a bigger shape, and then I can make a. Oops, it selected it again. Then I can make a bigger shape. And if I'd made this curve, the new shape I'm replicating would also be curved. Select the pointer. I can delete that. I can use the pull tool to lift that up, say 1 millimeter, and then I can build a thing in the middle to say 60 or however tall I want it, and that ridge is now independent of the main block, and that's how this was done. If you pick a shape, you take the shape of your object and you pull it out with oops, I picked up the wrong tool. Take shape of your object. You see how you can make the shape bigger or smaller with moving that line, and you see it's made that rim, and then I can make another rim, and then I just use the pull tool to pull that rim. Of course, I've done this on the top. It would actually normally be done on the bottom. Let's back that up and get rid of that because I don't need it. And that's how I've got rid of the warping. I know people use various concoctions of glues and sprays and all the rest of it, but I can't stand any of that. I find it horribly messy, which is why I went for Zortrax, because it's got this drilled with all the holes drilled in it. And sometimes when the thing is actually printing, I not only level a build plate, but I actually watch the stuff squishing out on the first layer, and actually slightly tweak the controls underneath if it's not printing flat. And I actually stand there and watch the first layer go down and adjust the controls a little bit, getting the plate level as it's printing. That's just an embellishment, and in fact it's probably not so critical in this printer because it's so well made, but on some printers it's that seems to work better. I know the Flash Forge Finder I had a nice, rather handy bed leveling procedure, which is fully automatic. But again, you would it wasn't as accurate as it could be, so you'd stand over it and you'd watch it put the first layer down, and where the layer wasn't squidging out on the raft, you'd tweak it up, and if it's squidging out too much, or it's pushing the nozzle onto the bed and the filament's clicking because it can't feed through, then you wind it down a little bit, and you kind of, with a bit of skill and practice, get a very nice first layer, and that helps. And but I actually often struggle with 3D printing. I didn't take to it as well as I could do, thought I would, and in the end the answer was to buy a good quality machine, and that was my way of solving the problem. There are people who like to tinker and fiddle, but I got fed up with that. This printer's done some nice things too, as has the its successor, same manufacturer. But the problem I found with these is getting the damn thing to stick to the bed. The amount of time I've wasted having prints fall off the print bed, even if they haven't warped, and then I'd be putting sticky stuff on and farting about with Captain tape and blue tape and this, that, and the other, and it sort of worked, but it was messy and stressful and irritating. I just want to make things. I'm not into playing with printers. I just want to make things. The Zortrax doesn't handle PLA. This does, so that's comes in handy for PLA. I do believe Zortrax have since developed a PLA head and a PLA filament, and this is when I bought this machine, it came with a reel of ABS. The manufacturer really shouldn't have supplied it with ABS, because you need an enclosed build chamber for ABS. It opens sides, it cools down too much and it buckles, and I basically, I actually didn't use this thing for a year because I had so much trouble trying to get anything out to do a decent print that I gave up on it. And it turned out that actually the problem was the filament that come with it was absolutely rubbish. I didn't realize filaments vary so much in quality, and the filament I had was so full of impurities. Black filament often is, because the black color disguises any rubbish they put in, so I kept getting nozzle blockages and the filament breaking, and it never occurred to me that the filament itself was a problem, and I was always blaming the machine. With decent filament, this machine can do some nice prints. This box was done on this machine, and I made a part cooling fan and a bracket. That's a really nice bracket that came out perfect. That was done on this machine. So these things have great potential, and now that I've learnt and become more experienced at it, I'm going to go back to it, because actually there's nothing wrong with that machine. I just didn't have the knowledge. And that's the nice thing about Zortrax. If you just want to make things and aren't interested in forever farting about with settings, this is the answer. But of course, it's been spending money. First thing I made on this machine to test it out was a huge benchy, as big as it could possibly go. But even then, because I was showing the machine off, I had the doors open, and look what happened. It shrunk. The shrinkage. It did the hull fine, but then I kept leaving the doors open because everyone wanted to see the printer working, even when I was away at work. And so I left the doors open, and the drafts got to it, and that's what happened. It all cracked. If I kept these doors shut, that wouldn't have happened. We've got a smaller one of these at work, the M200. This is an M300, and I've actually got an enclosure over the top, and I'll do that for this one sometime. And because draftiness is a major problem with ABS. And so yeah, I've had a good old rabbit. I can't think of anything else to say. How you design the thing that you're printing is really quite critical. And let me see if I can find something. I've just decided for something I want to see if I can get this. Apologising, my camera work isn't too good. I'm focusing on talking rather than what the camera's doing. And let's see if I can collection. Before I came up with the idea of just putting a ridge on, I had an edge, just a brim. I put a brim on, and the brim helps, but it's not as good as the ridge, I've discovered. And load this directly into the SketchUp model. There it is. So now what I've done, and I don't know if it's on this one, no it isn't, is this simple little tray has been a total swine to print. I had terrible trouble. You notice I've got the curved sides on it and all the rest of it. I've really struggled with this one. So this is actually printing at work over the Easter weekend. It will be done now because it's only a 12-hour print. But what I did was put a series of circular grooves in the bottom of it using the design, and of course I converted this raft into a series of ridges, and so hopefully that should cure the problem. But it's a specialized device made for work, and all of these straight runs which have to be that shape are causing the thing to pull off the print bed. And I've tried different filaments. I could do PLA, but of course the machine at work doesn't do PLA because it's the same as the one I got here, Zortrax, and it's the earlier one. And I could change the nozzle, of course, but ABS, I actually like the challenge of ABS now that I've made some progress. And by putting ridges and grooves and slots in the underside, it breaks up the straight runs, also using the low fill and the temperature of the actual filament. Zortrax ABS prints at quite a high temperature, and I find if you turn the temperature down, if you turn it down too much, the layers tend to separate. You get a grain. It can break more easily across the grain, but for something like this, that's not so important. Ultimate strength is a little bit sacrificed because the cooler the filament comes out of the print nozzle, the less it shrinks when it's cooling down and the less warping you get. So high as possible bed temperature, low as possible filament temperature. Well, I just come down 5 degrees now from what Zortrax recommend, or the manufacturer recommends. And there was something else I thought of which is quite significant and blow me, I've just forgotten it again. Yeah, the speed, the printing speed, that's it. The printing speed, set the slowest speed you can. That does seem to help. And so whenever I'm doing a job, say overnight at work, I set the printing speed so that it's going to take the whole night. That seems to help. And because as the layers are building up, the layers underneath are trying to curl up, but as they say, stay there for hours and hours on the hot bed, the plastic kind of relents and stops trying to curve because it's just been held down, and that helps as well. I can't think of anything else, and I've rumbled on for long enough, and so I'll put this on YouTube, and I'll add anything else that I think of in the text underneath. Sorry it was so long. If I knew how to use an editing software, I'd take all the rambling out and just make it a much shorter video, but it's nonetheless, and I'm sure it'll help. And so that's my story so far. What I don't use is glues and tapes and all that messy stuff, although sometimes a very thin layer of ABS washing down the plate acetone does seem to help. And because you're not adding stuff to the build plate, you're kind of removing it, cleaning it up. And that's the other thing on these printers, making the plate absolutely squeaky clean makes all the difference. You can have a glass build plate, which I've got on that, and the print won't stick, and then you get it absolutely squeaky clean, and the next time you have a print it does stick. So getting the plate absolutely squeaky clean seems to help. And so that's been a lesson and education too.